Hello developers, let's start developing. So it's the 5th of December, which means that we have the fifth task of 2024's Advent of Code. Let's read through it first. Actually, let me see what the input is, whether we will need to do some weird parsing. Seems that the input is actually in multiple parts. Anyway, this is trivial to parse and this is trivial to parse as well, but we will need to write some code. Yeah, so we searched on Ceres, didn't find the historian. The stationary stacks of sub-basement 17. Oh, we have a printer that we actually, the whole story of year 2017 was about fixing a printer, which is the bane of every IT guy's existence. Won't print correctly, safety manuals, safety protocols, new pages. Oh, we need to basically do a build order. We need to create a make file for this. What should be printed before what? This is always an interesting problem. X and Y. X must be printed before Y. Page ordering rows and pages to produce in each unpad. Whether each update has the pages in the right order. Oh, we just need to check it. So we have the page ordering rules, means now page number 47 must be done before page 53. Okay. Okay, so so I guess the second part will be actually make it in the right order. Which updates are rolled in the right order? Example. Okay. Okay. The fourth update is not in the correct order. 75 before 97. The middle page number of each update page printed. Only printing the correctly ordered updates, find the middle page number. Okay, makes sense. So, let's start with parsing the input. First time this year that we do have a more complicated input that we're gonna need to parse, which means that we're gonna need a type for that. Type input, it will be consisting of a rule set, which is an array of a pair of numbers. So this is a set of tuples of numbers. So the first one goes first, the second one goes second, and the other thing is the page ordering rules. Those are, and these are updates. And this is a number array. So this is literally a matrix of these numbers. An array of arrays of numbers, technically. This is not a matrix. Even though one matrix is also an array of arrays of numbers, it is a bit of more in the square shape. This can have in this specific case, the lines are basically unrelated. So instead of returning and using the string array, we're gonna use our input type, which means that we're gonna need to return an input type. So we're gonna say the rule set is empty, the updates are empty, and then we're gonna return the result, and everything is okay, except here we don't have a length specifically, so I will just return -1. I'll exclude part 2 for now. We'll see what happens after we do that. So the first goal, right now we're ignoring everything else. Our first goal is parse the input correctly, which means we have our lines. So now for each line, actually I will do something like a loop and a half. Let current line is lines of 0. So we're taking the first line. And until the current line is not empty, we're gonna get the rule set. And after that, we're gonna get the updates. So those are the two parts because they're separated by a single empty line. So initially we should process these 20 lines, 21 lines first, then skip this one and then process these 6 lines. So we're gonna get the rule sets. We don't have your ticket. This is just some hallucination from Copilot for the current line. Well, we will need to do everything and then say current line is lines.shift. Maybe we should use shift here as well. This actually takes the first item and puts it in this variable while removing it from the line strings. So we're always taking the first element and removing it, taking the first element and removing it. So here we will have to say current line.split on a pipe, and that should give us an array of 2 numbers and of 2 strings, and then we will map the value to percent of that value in base 10, and this should give us these 2 numbers, and I can say const rule set is equal to this. Now this will be decided that this is actually an array of numbers, but we know that it's exactly 2 numbers, so I will actually specify that this is a pair of 2 numbers. And then or we can alternatively just make sure that this is that. We're gonna say we're not making sure, we're implying that we know more than the compiler, and in this case we do know more than the compiler. We can take a look at input.txt, the compiler cannot. And then I can just say rule sets result dot rule sets dot add the current rule set. Why is this a problem? Oh, because the result is defined kind of after that. We need to move this here, and now the result didn't infer anything. I will just say, well, this is an input. And if it is an input, now the types of the rule sets and updates properties are correctly inferred. We will skip getting the lines. I will just say console log the result here, or just the rule sets. Let's run this and see if we get the correct rule sets for now. We kinda don't, which means that we have a bug somewhere. Then the bug is here. I'm saying while the line is empty. No, I'm supposed to say while the line is not empty. And it says, well, it could be undefined. Actually, I will just say it like this. While the line is truthy, or use this trick so it actually casted to a boolean. So while the line is truthy, continue. And when the line becomes empty, it will become falsy, and we will finish our processing for the rule sets. Let's see, we have 21 rule sets. It's an odd number anyway, so 3, 3, 3, 1, 21 rule sets, and it seems like those are the ones that we kinda needed. Let's see, it should not you, but you, it should end with 5313 and start with 4753. And these are numbers, which means everything is great. Now, our current line is empty and we need to actually skip it. So first thing that we're gonna do is we're gonna skip it. Take another line. And that's the first line that we have. And we can also use this because now we're not gonna get to an empty line, but we're gonna run out of lines. So when we shift out of an empty array, we're gonna get undefined. Undefined is false, so this will stop. At least I think so. And now this thing kinda got it right, because now we need to get the values split on a comma, not on a pipe, and cast them to an integer. Now this is correctly an array of numbers, because that's what we need. Push them and take the next line, and let's just say console log, oh, not confirm log the result dot updates. I only want to see the updates. Let's see what we get. We should get 6 items, and that should have respectfully 553, 535 items. 553, 535 items. The items look correct. Starts with 97, ends with 47. Yeah, it's that. We're good. So, first part of the task, totally done. Whatever we're doing, we cannot go back on this. This is fixed. We have our input correctly here. And now we need to actually solve the task. So, in principle, we're gonna need to loop through each of the updates and check it against the rule set. And if that check returns true, then we just need to find the middle one. The result is the sum. Add up the middle pages. Yeah, we need to sum it up. So will be, this is the result. It's gonna be 0 initially. If the check update returns true, then the result will be plus update of update.length divided by 2. This is a stupid way to calculate it, but it will work. No, it won't, because the length is 5, half of 5 is 2.5, and we need 0, 1, 2. So we need 2, and since we are kinda guaranteed that this thing will have an odd number of elements, because if it doesn't have an odd number of elements, then we don't have a middle part. And actually, let's check that on the big input. I cannot guarantee it, but for example, you can see lists the updates that are this big and this big, but you don't see an update that's in the middle. We can run a quick code to check, but for now, I'm just gonna assume it. And document that assumption. Yeah, that one. Now we have the small task of actually writing the check update, which take an update and take a rule set and continues. So Let's do a stupid brute force check. For each of the items, we're gonna take all parts of pairs of numbers. Now we're gonna use another for loop that goes from, yes, from here to here. We get the second one. Oh, I think this is exactly what we now want. So I don't think this is what we want, but let's break it down. So we're taking a pair of elements. What we can guarantee, because we're starting from index plus 1, we're guaranteed that the second one comes after the first one. So we're not taking any random pairs, we're taking all the pairs where the first one is before the second one. So for this thing, we will take 7529, 7513, and 2913. Those are the three pairs that we need to check. And we need to check whether we have a rule set that breaks this. As is explained in the task, if something is not defined, it's okay. So we just need to find places where we explicitly break stuff. Let's see. And that means that in the rule set, there has to be some rule where yeah, the rule has a first and a second element. Actually, I will call this rule F rule, or an S rule. Sounds better to me. Where? What should be true? That the second number should be equal to the F rule. Oh yeah, this is bad. This is bad. We don't need that. We do actually need something like that. And this is yet another place where doing the defaulting, because copilot will always give you what makes sense in this context. And it makes sense to basically look up a rule, disregarding the ordering. But it doesn't know that we actually need the ordering. So this is what we actually need. We need to find a pair that is the other way around, a rule that is the other way around from our pair. So let's go back to the example. So we would have to take this pair 7597, and since we have a rule that says 9775, this is invalid. Actually, I will add a console log here. Failed, let's say failed update. And since this is an array of number, it will display nicely for first and second. Yeah, we don't need to find the rule because, of course, there's a rule that says the other way around. And that's all we do. If every possible pair checks out, note that this is a quadratic complexity algorithm, because we're not doing the optimal, we're not hunting for rules, we're not checking the rules and things like that. There are plenty of better solutions, and I feel that this can be optimized. But one thing that we get by extracting this to a method, if we optimize it, this code doesn't change, and this code we know it's correct because run through the updates, check them. If they are okay, add them up, and that's all there is. I will also add a console log here. that update passed. So let's check if something happens that goes along the lines that we want to do. It says failed update 7547 for 75 and 47. Why? I don't think I saw such a rule. 47. Actually, let's look at the input. We don't have a rule that says 47 should go before 75. Totally don't have that. We have the other way around. Let's see if our check is correct. Because we have first is 75 and this is 47. There is a rule where did we fail all of them on the first pair? 97, 61, 75, 29, 74, 47. No, we didn't fail on the first pair. We passed some pairs. This failed on the first pair, this failed on the first pair, and I have a feeling that 97 is not present in the data in that way. We're definitely checking the wrong part, because this is the only thing that passed. That 97 should be before 75, and that's the only thing that passed. I don't know, let's debug some more. Actually, we might want to do some proper debugging like this, but for that I need to start the code from the terminal inside the VS Code. Let's do npm start 5, and this attaches a debugger, so I will be able to actually stop on a breakpoint and look into it. So of course we have our update, which is the first one, 7547. The first item is 75, the second item is 47, the rule set. It has 75 and 47. So f rule equals first and f rule equals second. Let's see if we have a rule set when 75 is on the second place. Now, this will only and only match. Let's rewrite this a bit. Instead of this, I will make it a full-fledged method and do a lot of more writing. So return true, return false, but here I will add a console log. No, here we're actually falling. Oh, Copilot is an asshole, and I am sad that I didn't see that earlier. Always, and I mean always, look at the code that generated for you, because we did all the logic correctly, we just negated it. Let's see if this works now. past update, failed update for 75 and 97, failed update. So 13 and 75, let's see the sixth one. 29, 13, 13 and 29, yeah. 75, 97, 75, 97. We are displaying them not in the specified order totally, but yeah, and the result that we're getting is -1 because, as usual, we forgot to display the result. Let's see if we get 143. And we're getting. Again, this is not an optimal solution, since the checking is way too busy. We're checking everything, but seems to be working. Let's check it with the huge input when we have, I guess, 1,000 rules, more than 1,000 rules, but not too many updates, a few hundred updates, which are relatively small. And for a relatively small, a quadratic complexity doesn't really make a huge difference. So this should be fast, and it is. It took us 84 milliseconds. Sure, it can be faster, but 84 milliseconds is not a huge number. Let's see where we got wrong, or we didn't get anything wrong, since this is the right answer. Let's see if I'm right about part 2. You have a little too. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. Only the incorrectly ordered updates and ordering them. And I guess, yeah, we need to get the incorrectly ordered updates and then work something with them. So in essence, now I will paste the first part into part 2, because we're gonna totally need it. And I've mentioned previously a few times before that I want my part 1 and part 2 to be completely separate. They're independent of each other. I'm not gonna use the result in from part 1 from part 2. If I do need it again, I will redo it. In that sense, yeah, we will have result, but we will also have invalid updates, which is actually this. We can have it like this. So we're gonna filter the updates and only take those that failed the checks. Of course, we can rewrite this with a filter and a map, but it's gonna be functionally identical, so I'm gonna leave it like that. So now we're gonna do something like this. Of course, this is gonna return a total number of 0, because we're checking something that we know that's not gonna work. Let's see if this gives me a 0. Yeah, a nice big fat 0 for the big input, and we don't want the big input, we want the small input so that we can test only those 6. So now we need to find the first rule that is broken and then swap them. And I have a feeling that we might need to continue doing that, because if we have a set of things that see this, because this has 97, 13, 75, 29 and so on. We need to change quite a bit items. 47 becomes third, 75 becomes that. So I will do yet another inefficient solution. I will have a fix update method that will generate a fixed update. And the fixed update will be valid, which means that we don't need to do that. We will still do this, and that will be the goal. And of course, this is gonna take the rule set and an update and return a fixed update. Not really so far, but this will compile and this will work. So I will reuse most of the logic for this from the check update. As I'm saying, I'm intentionally making something that is suboptimal but works. It will give me insight into what is going on, or I might get lucky and for my input that I'm using, it's gonna be quite okay. If that's the case, then we're fine, we're golden, we'll just leave it be. If that's not, we have a place where we can optimize, but we're optimizing by refactoring something that is already working. So what I want to do, I want to find the first index where we have a problem. Let's extract that to yet another method. Yes, something like this, and instead of returning false, we're just gonna return findex and syndex. Otherwise, we're returning two minus ones. Or we can just return null. That's also valid because I want to do a null check. I'm gonna do a null check. So we're taking that thing, we're finding the problem indices, and if we don't have problem indices, then we're just returning the update because we're done. But if there are problem indices, yeah, we can take them in and we can swap those two items in the update. Yeah, take the update, take the first item, take the second item, and the update, the result of the first item is the second one, the result of the second one is the first one. So this is a kind of a convoluted way to actually find the problem indices and swap those two elements. Since they are problematic, they need to be they are the wrong way around. And if we swap them, then we can just continue. See if this is still problematic. So we will need to redo this code. So instead of doing that, I will put a while here. While the problem indices are a thing, do this. And now we don't really have to call check update because problem indices is about the same. I can say find me new problem indices. Find them on the result and the rule set. And we're gonna go through this again and again and again and again. Result is a copy of update, and then we are actually working with the result, and we're not changing it so it can be constant. We're just swapping them like that. Now here we don't need update, we're gonna return the result. We can make this into a one-liner or something like that, but this is actually kind of cleaner code. We see we are taking those values and we are exchanging them. And at the very end, return result. Now, what could happen here if we have a specially maliciously crafted input? We might get into a situation when we keep swapping and swapping and swapping and swapping, and this never finishes, but we'll see if we get to that scenario. For most of the cases, I have a feeling that a single swap will be done, and we got that the result is 135 now. And it should not be. Well, let's see. Oh, the result should be on the fixed array and not on the initial array. Let's see if this returns 1, 2, 3. Yes, it does. Let's console log the fixed. We have those three. It says I've changed it to that thing, changed it to that thing. The first two are easy. The third one, you can see 97, 75, 47, 29, 13. Looks about right. Yeah, okay. I'm not sure that there is not a more complicated, way more complicated thing over here that we might not run into an endless loop, but with code it's easy, one way to check up. So if this thing runs forever, and it didn't, it actually fixed it, we might have that issue, but we saw that we got a result. Is this? Yes, that's the correct way. Now we have 10 stars, and this is a relatively nice problem in the sense that the solution is a bit of a hack, let's say, is a bit of a brute force-ish thing. Actually, I might add this here. So this is a nested method of the fix update. It's not outside of it, so we can just look at it like that, but it doesn't really make any kind of difference. We can have it like this as well. The code, this part of the code is totally simple, but this part of the code is totally unnecessarily complex since this is actually a triple nested loop because we have two nested loops here and this is a third one, which means that we have even higher complexity. But we have a limited amount of data, and especially if we remove this console log, we can see how long it actually takes. It's gonna take way less than a second. It will take some time. Oh, it took 2.5 seconds, which I don't really like, which means that we might need to optimize this, but still it is relatively fast. For now, I'm okay. Usually my goal is to have all the tasks run in under a minute, and I think I have a command for that. Let's see if it works. Oh, now it's gonna break because now it gave me. So the task for day 5 takes out 97% of the processing time. This will change as we get to the more complicated tasks. But anyway, I'm quite okay with the solution that first works. Let's see if we need to optimize it, and if we do need to optimize it, you will get a part 2 video. Anyway, don't forget to mash those buttons, and talk to you later. Keep developing.